In this lesson, we're going to talk about how to solve linear inequalities in two variables. First, what is a linear inequality? So linear inequality is kind of just like what it sounds like. If you think about a linear line, y equals mx plus b, or ax plus by is equal to c, right? Those are linear equations, but now let's make them inequalities. Something like that. Now those are linear inequalities. And what happens there is we're going to graph them, and then we want to be an inequality. So we're going to have to either be above this line, greater than this line, or less than this line. And we're going to shade the correct method. And all our solutions to that will be the shaded region, right? So any points in this shaded region will be our solution to this inequality. Any points in the opposite region will not be the solution. One way to check, if I give you order pair, how do you check if it's inside the inequality? Just substitute it in and see if it holds true. So like here, right? This is x minus y is less than or equal to 5. Our x is 8, our y is 3. So let's substitute it in. 8 minus 3 is less than or equal to 5. 8 minus 3 is 5. 5 equals 5. That's true. Could you be less than or equal to 5? So this is inside. A3 is the solution. We go on to this next one here, right? So 6 and 2. So 6 is x, y is 2. So we're going to substitute it in. So this is 0.5 or 1/2 times 2 minus 1/2 times 6 is greater than 3.5. Lots of decimals in this one. 1.5 sitting is 1/2. 1/2 times 2, they cancel out, you get 1. 1/2 times 6 is 3. And that's greater than 3.5. 1 minus 3 is negative 2. And this is not true, right? Negative 2 is not greater than 3.5. So no, this is not a solution, right? It didn't make this thing a true statement. It has to make it a true statement. Next one is to check real quick. Here's my x, here's my y. So to substitute it in, I get 2/5 times 1 plus 2 is greater than or equal to 2. So I get 2/5 plus 2 is greater than or equal to 2. Well, 2/5 plus 2 is just like 2.4. And that is greater than 2, right? Again, you don't have to be exactly the same. You can also be, it has to be true. 2.4 is greater than 2. So this is also true. So this is a solution. So that's the easiest way to tell if a point is in the solution. Just substitute it in, see if it holds true. Now let's talk about how we graph these inequalities. Those final steps. So first, we're going to graph the boundary line. That means we're going to graph our equation. Use it slope-intercept form. Second, we're going to decide if the boundary line is part of the solution. So that means when we graph our line, is it going to be solid or dash? Very simple. Let's talk about the line here. So if the line is less than or equal to, greater than or equal to, right? The equal to part is the important part. If it's equal to, then it's made a closed circle, or for here, a solid line. If it's just greater than or less than, so not equal to, then it's an open circle, or for us, a dashed line. Remember when we did like the number lines, right? So equal to was a closed circle. For us, in this case, it'll be a solid line. Less than, greater than didn't have the equal to sign, so it was just an open circle because you couldn't be the number. In that case, we'll show a dashed line. After we do that, then we have to decide how we shade. So we can either shade above the line or below the line. So how do we decide? There's two ways. One way is you pick a point anywhere on the graph, and if it works, like if it's a true solution, then you shade. If it doesn't work, you shade the opposite. That's one way to do it. The other way to do it is you can do it this way. Shading, right? We have less than, we have greater than. Equal to doesn't really matter here. It'll be the same. If I say you're less than a line, because that's what we're talking about, the line, then I would expect you shade below it, right? You're less than it, you're below the line. If I say you're greater than the line, and then you're going to shade above it, because you're greater than the line, you're above the line. So that's how shading works in general. So to recap shading, if the y value is isolated by itself on the left-hand side, so we have it in standard form, much like y equals mx plus b, then less than is just below, and greater than is above. But you can always just use a test point like you did here to see. And again, if it works, then you shade that area where the test point came from. If it doesn't work, you shade the opposite area. Okay, with all that in mind, let's do a couple examples because it's a lot easier than I probably just made it sound. So first, let's do this one right here. So it's already in standard form, so that's good. Next, let's see if we're going to do a solid line or dash line. See how there's no equal to sign? So it's going to be a dash line. And this is less than. Always think with less than, it looks like you spell less. So it's less than So we're going to shade below. So dash line, we're going to shade below. So other than that, let's just graph it. Right, so my y-intercept is -3. So my b, my y-intercept, so we're going to start at -3. Our slope for m is 1, right, coefficient of x. So the number from the x is 1. So our m equals 1. We'll put that 1/1. So we're going to go up 1, right 1. So 1, right 1. Up 1, right 1. Now, in this case, again, we do not have a solid line, so it's going to be dash. So we're just going to do a dash line through these points. Like that. And then the final part, we got a shade. So again, it is less than, so I could shade below this line. And that would be my solution. Like that. Okay, next one. Right, so a couple things again. It is a solid line, so this should be solid. And it's greater than. So that's going to be above. We're going to shade above. We're greater than the line, so we're going to be above the line this time. And then let's graph it. Our y-intercept is 3, so start at 3. Our slope is -2/3, so we're going to go down 2 and right 3 from this point. So down 2, right 3, right there. This one's a solid line, so let's make this solid. And then we're going to shade above it. Like that. That's the whole idea. Now, sometimes we don't give it to you in slope intercept form, right? You got to put it in slope intercept form. So if I'm going to graph this one, I mean, you could do x, y intercept if you want, but the general easiest way is just put this into slope intercept form. Y equals mx plus b. Right, so let's get the y by itself. So minus 2x from both sides. So I have 3y is less than or equal to -2x plus 6. Then we're going to divide everything by 3. You get divided by 3. You get divided by 3. So y is less than -2x over 3 plus 2. Right? So like that. Now we can graph it. Our y-intercept is 2. Our slope is -2/3. So we're going to go down 2 and right 3. So right there. This is a solid line. You see the equal to sign. So solid. And then it's less than. So I'm going to shade below. So solid line, and then we're going to shade below. Now let's do a test point. We haven't actually done a test point yet, so let's do a practice test point. Let's pick a point like here. So that's 4. Let's pick a point like here. That's the point 3, 2. Right. So let's talk about how test points works. So I'm plugging 3, 2 into this. So 3 is my x, 2 is my y. So I get 2 is less than -2/3 times 3 plus 2. 3's cancel out. I get 2 is less than -2 plus 2, which is 2 is less than 0. Right? That's not a true statement. That's false. So that means I don't want to shade where I put my point from. I pick my point from the top here. I don't want to shade that. I'm going to shade the opposite. Like that. Which falls in line with the fact that it's less than. It should be below. So that's how a test point works. If I would have picked a point on this side, it would have been a true statement, and I just shade that area. Okay, let's do this one real quick. So same idea. I got to get the y by itself. If we want to graph by using slope intercept form, so minus 2x from both sides. So I get -5y is less than -2x minus 10. I divide everything by -5. So key thing here. Do you remember what happens when you divide by negative in inequality? So I'll take care of all this first. 2x over 5, right? 2 negatives make a positive, and over here 2 negatives make a positive. But I haven't talked about the inequality yet. Remember, when you divide by negative, you have to switch the inequality. So this gets switched to greater than. Right? Because if you divide or multiply by negative, you got to switch the inequality. Okay, so that's our graph. A couple things, right? Notice it is dash, not solid, right? No equal to sign. So it's going to be dashed. And it's greater than, so it's going to be above. Right? This is a greater than sign. Greater than is above. Less than is below. So our y-intercept is 2. Our slope is 2/5, so we're going to go up 2 and right 5 because it's positive. So up 2, right 5. Right? Rise over run. Right? Top is always up or down. Bottom is always to the right. It is a dashed line. And it is greater than, so we're going to shade above this line. Like that. All right, so that's the general idea. Okay, let's move on. What if we only have one inequality? How do we shade this? Just like we would a number line. So x is greater than 3. So remember the way we graph that? For me, it's always here's x, here's y, go to 3 on your x right there, and then you follow the tally marks. That's straight up and down. Same rules apply as we did over there, right? So if you notice, this is going to be solid because it's equal to. So something like this. Right? And now which side do I shade, left or right? So for me, it's telling you what numbers are bigger than 3. These numbers are bigger than 3, right? It's telling you go shade this way. It's pointing that direction. So that's the way we shade. So there we go. And if you always want, you can plug a test point in, right? Pick a point like over here, like 6. 6 is greater than 3? True. Shade. Pick a point over there. -3. -3 is not greater than 3. So don't shade this part. Shade the opposite. It works the same for y, right? Y is less than -1. So here's my y. Go to where y is -1 at. Follow the tally mark. In this case, we are dash. There's no equal to sign. And then it is less than, right? You can spell less there. So remember, less than is below. So we're going to shade below this line. Like that. Right? So if you have an x one greater than to the right, less than to the left. If you have a y one, up and down is pretty straightforward. Greater than, less than. Okay, one last thing. What if I want you to make an inequality? Ooh. Right, so in this case, since they're lines, we probably want to do y equals mx plus b. Right, but we do have to change this portion right here. Right, you got to make that an inequality. So first, is it equal to or not? Actually, first we saw, is it greater than less than? Look at here, right? It's shade below. So that should be a less than sign. And then it's dash, so no equal to sign. So we actually get this equation. Y is less than mx plus b. Now all we have to do is find the slope and find the y-intercept. Right? Those things hopefully we know how to do by now. Our y-intercept's probably the easiest. Where does it cross on the y? Looks like it crosses at 3. And then our slope, remember you always do slope the same way. You need 2 points. Slope, need 2 points. Right? So we have 1 point there. You can find another point that crosses nicely, like right here. Right? And you could do the slope equation, y2 minus y1 over x2 minus x1. Or you could do rise over run. Right? And that's just the change in y over the change of x. So here, we ran 1 and we went up 2. So my slope is going to be 2. So we get y is less than 2x plus 3. All right, okay, let's try to do the next one now. Y is equal to mx plus b. And this one, if you notice, it's shaded above. So that's going to be greater than. And then it is a solid line. So that's going to be equal to. So this guy should be greater than and equal to, like that. Now we just need the slope and the y-intercept. Y-intercept is right there. Looks like -1. Slope, we'll just find 2 points, as always. You always need at least 2 points for slope. So I would say this one right there crosses nicely. And let's do this one right here. And those two look nice. Right in the corner. So we're going to go, remember you have to go left to right, this way. Left to right. So I have to go down 1 and right 2. So my slope's going to be -1 over 2. So y is greater than -1/2 x minus 1. And that's the idea.